Assalamualaikum semua. Okay, so for this week, we'll try to cover topic 17E, okay, and we'll try to cover 17F. Okay, so we'll do 17E first. Okay, the title is Independent Events, page 525. Right, so before I begin, okay, let's do a recap of a formula. Okay, you still remember this formula? Okay, which is on page 522. Okay. Okay, so probability A intersect B is equal to probability A times probability B given A. Okay, so now we're going to start off with this topic of independent events. Okay, so let us make sense of it. Okay, what's the meaning of independent events? Okay, so you have learned in Sec 4 or Sec 3. Okay, independent events are events that is not linked one with the other. Okay, so for example, when you flip a coin, okay, you flip the first child. Okay, if let's say it's a head. Okay, that doesn't mean that the second child will be a tail. Okay, the probability of each event is independent of one and another. Okay, so that's the meaning of independent events. Okay, so what it means truly in terms of probability. Okay, let's look at this. Let's look at this only. Okay, probability of B happening given that A has happened. Okay, so if you want to think of it as the flipping the coin, probability of the second child getting a head. Okay, that particular probability, okay, given that previously it was a tail, for example. Okay, let's say this is head, this is tail. Okay, so the probability of getting the head will still be half. Okay, it is independent. Okay, so that means the probability of B given A will still be the same as probability B. Okay, that means A has no effect on the probability of B. Okay, that's the meaning of independent events. Okay, so we have this particular identity. Probability of B given A for independent events must always be equal to probability of B. Okay, so if we have this and we learn this earlier, okay, let us try to put it back into the equation. Okay, so what we can arrive at would be probability of A intersect B, okay, is equal to probability A, but for this part, it is actually probability B. Okay, so you want to find the intersection. Okay, for example, probability of head in the first child and probability of tail in the second child. Okay, all we have to do is multiply both probabilities together. Okay, so that's the meaning of independent events. For independent events, okay, what we can say is the intersection of A intersect B. Okay, the probability of that must be equal to the individual probability multiplied together. Okay, so we'll take a look at a few work examples first. Okay, so I need to turn to page 526. Okay, so while I erase the board. Okay, so our focus now will be on this particular identity. Okay, so let's look at page 526, work example 17.9 first. Okay, so you're given probability A is 0.5, probability B is 0.2, okay, and probability A union B is 0.6. Okay, are the events A and B independent? Okay, so you need to make use of your previously learned formula. Probability of A union B. Take note, this is probability of A union B, not probability of A intersect B. Two different things. Okay, so probability of A union B is probability of A plus probability of B, and then you must remember to subtract probability of A intersect B. Okay, So this is a previously learned formula. So let us plug in all the numbers that are given. So A and B is given as 0.6, A is given as 0.5, B is given as 0.2, and then we minus away this probability of A intersect B. Okay, rearranging this, we will arrive at probability of A intersect B is 0.1. Okay, so what does this tell us? Okay, we need to check whether it's independent, right? So we have this probability of A intersect B to be 0.1. Okay, so look at this. What we need to do is, if on the left, probability of A intersect B is 0.1. On the right, it has to be 0.1 if it is independent. If it is not, then it will be another number. Okay, so let's check this. Okay, probability of A, let's check the one on the right. Okay, times probability of B is, or our A is 0.5. Okay, our B is 0.2. Okay, when we multiply these two together, we get 0.1. So since probability of A intersect B is equals to probability of A times probability of B, we can say that A and B are independent events. Okay, so as you can see that probability of A intersect B is equals to probability of A times probability of B. So A and B are independent. Right? Okay, so I leave you to read work example 17.10 first. Okay, while I erase the board. Right. So welcome back. We are now going to look at work example 17.10. Okay, let's read the question first. A and B are independent events. Okay, so it's mentioned here that it's independent. Okay, with probability of A union B to be 0.8, probability of A to be 0.2, you are supposed to find probability of B. Okay, right. So it's different from the previous example. Previous example, you're supposed to find out whether it's independent or not. But for this example, you're given that it's an independent event. Okay, so what we can do here is we make use of the previously learned formula. Probability of A union B is equals to probability of A plus probability of B minus probability of A intersect B. Okay, so we learned that before, right? Okay, so plugging in all the values, we put 0.8 over here, 0.2 over here, but probability B we don't know yet. Okay, but the thing about this probability of A intersect B, because it's independent, this statement holds. That means to find this probability of A intersect B, we have to multiply the individual probabilities of A and B together. Okay, so they write it as okay. Let me write down as probability A times probability B first. Okay, so it's easier for you to understand. Okay, so plugging in all the values, I get this probability B over here, but here I have 0.2 of probability B. Okay, so what happens here is that this one is 1 of probability B. This one is 0.2 of probability B. You can actually subtract it. Okay, so it's actually equals to, if I bring this 0.2 over, so I get 0.6. Okay, is equals to this 1 minus 0.2. So it's 0.8 of probability B. Okay, so how do we find probability B? We just have to divide this 0.8 over here. So probability B, when you divide it, will be 0.75. Okay, so that is how we attempt example 17.10. Right? Okay, so for practice, what I need to do, let's look at question 1 first. Okay, for exercise 17E. Okay, in this question, assume that events A and B are independent. So this question, they want you to assume that A and B are independent. Okay, but for question 2, you're supposed to determine whether they are independent. Okay, so I want you to try. We break up into groups. Okay, then some groups will try A, some groups will try B, C, and D, and then after that we discuss the answers. and then later on, after we finish that, we'll do question 2 together. Right? Okay, so can you go ahead and do question 1, A, B, C, D. Okay. Alright, so question 1 and 2, I believe that they're quite straightforward. Let us try to look at question 4. Okay, it's a green question, okay, where they make up a story and we are supposed to make sense of it. Okay, so let's read. They say that a school has 2 photocopiers, okay, one for teachers and one for students. The probability of the teacher's photocopier working is 92%. The probability of the student's photocopier working is 68%. The two outcomes do not affect each other. Okay, so which makes sense. If this photocopier is not working, it doesn't mean that the other one will not be working. Okay, so what is the probability that both photocopiers are working? Okay, so from here we are supposed to understand that this particular event, both particular events, they are actually independent. Okay, so when we want to find out both photocopiers are working, okay, so let's call T be the probability, be the event that the teacher's photocopy are working, okay, and then S to be the event that the student's photocopy is working, okay, teacher, student. Okay, so what we will find is both photocopiers working means probability of T intersect S. Okay, but since they are independent, we know that it is actually equals to probability T times probability S. Okay, the probability of the teacher's photocopier working is actually 92%. Okay, so we plug that in as 0.92. Okay, the probability of the student's photocopier working will be given as 68%. So you plug it in as 0.68. Okay, so multiplying that out, let's calculate. 0.92 times 0.68. You get 0.6256. Okay, so that's for part A, right? Alright, so now we are going to do part B, which is neither photocopier is working. Okay, so this one needs a little bit of thinking. Okay, if you were to look at the Venn diagram, okay, this is T, this is S. Okay, neither photocopier are working represents this one. Okay, anything outside the 2 circles, okay, or 2 ovals. Okay, so how do we find that? What we need to do is we must first find these 2. Okay, these 2 circles together. After that, because this complement, right? So we're going to do 1 minus that. Okay, so let's try that. So to find these 2, okay, in set notation is actually probability of T union S. Okay, so T union S is given as probability T plus probability S, okay, minus probability of T intersect S. Okay, so we try to find this first. Okay, probability T is given as earlier 0.92. Probability S, if I remember correctly, it should be 0.68. Okay. Subtract away the previous one we calculated earlier, probability T intersect S to be 0.6256. Right, so let's calculate that out.
0.92 plus 0.68,
okay, so I get 0.9744. Okay, but the one that we want is both copiers not working, so it's probability of T union S prime. Okay, the complement. So 1 minus probability of T union S. Okay, So 1 minus 0.9744, you will get 0.0256. Okay, and that's how you do part B. Okay, so we're gonna go do part C. Alright, so we'll take a look at part C. They want us to find the probability of at least one photocopier is working. Okay, so what's the meaning of that one photocopier is working? So either teacher's photocopier working, okay, student's photocopier working, or both teacher and student photocopier is working. Okay, either one, the other, or both. Okay, so in Venn diagram again, what we are interested in will be this one. Everything within the circle. And for this, we have actually calculated earlier. Okay, that probability is probability T union S, okay, which is 0.9744. Okay, right. So we are done for question 4. Okay, thank you very much.